Okay, here I'm proceeding into problem number 12. Now I skipped problem number 11 because you can find a similar problem in the example that I offer over in the video clip that has the general discussions for solving logarithm equation. So now in here, this problem here, and in fact this problem here would also be similar to the problem we had in the general discussions. However, it's worth to mention a little bit. So the only matter now is that once again, my equation here is already, it's in ordinary form, which is what I have here is one singular log of a base 2, and then there's some expressions, and then equals to a number on the other side, and no coefficient in front. That's what I mean by ordinary form. So now to solve this equations, the only thing I can do is, the only access for us here is to rearrange these three. Now, as you see, I underline that 2, that base 2, and I underline this expression, and I underline the number. Those three quantities right there, we need to learn how to, you need to get comfortable with rearranging them in the appropriate way. So, 2 is your base, you write it here. The number on the right hand side would now become the power for that base 2, and then that would be equals to x minus 4, which was the expression from your log expression. So now here you have a new equation to solve for. So now, by the way, the reason I pay attention to this problem here is because I would like you to get comfortable once again with the negative power. So 2 to the negative 3 would be equal to 1 over 2 to the third power, and that would equal to x minus 4 on the right hand side. And then in the next step over, you can think of that as 1/8 equals x minus 4. Okay, so now to solve this problem, everything becomes easy. You can just simply multiply both sides by 8, right? And so my 8 here would eventually cancel, and I have 1 equals 8x minus 32. Okay, minus 32. And so adding a 32 to both sides, and that would give me 8x equals 33. And then I'm dividing both sides by 8. Right? And that leaves me x equals 33 over 8. Now, once again, keep in mind, we are solving the logarithm equation, so do not forget to check. Don't just rushly circle your answer here at this point. You have to check the answer to make sure that the two sides equal. So what I do here is I'm going to plug 33 over 8. I'm plugging 33 over 8 into my starting equation. So I'm going to have, so my checking work here, let's see if it's going to work out. Okay, so I have log base 2 of 33 over 8 minus 4. And is that going to be equals to negative 3? That's the question. So now let's work it out, okay? The left-hand side, you have evaluating the left-hand side, you have log base 2. Now, of course, if you're feeling fuzzy with your fraction skill, make sure you have to get that going before you go back and understand this problem, okay? But when you subtract 33, when you do 33 over 8, subtract 4, what you need to do is make common denominator. So now I'm going to go 33 minus 32 over 8. That's how I made my common denominator. And then that's still not clear, isn't it? So we still don't know if it's actually equals to negative 3 on the left-hand side. So now over in the right space right here on my paper, I can see that we have the left-hand side will become log base 2, and now we'll go ahead and computing that calculating that further, I have 33 minus 32, and that would give me 1, and that would be over 8. Okay? So now clearly, log base 2 of 1 over 8 equals to negative 3. So now my two sides are checked to be equal. So now you can go back and circle your answer here as your final answer. X equals 33 over 8. And that's how you solve problem number 12. Okay? Problem number 13. We would like to solve again. And this time, once again, you can imagine ahead of time that we are now, once again, we are now keep looking into logarithm equations here. Right? So I have 5 plus ln of x. I have 5 plus 6 natural log of x equals 17. Okay? And we would like to solve for x. And now, furthermore, we would like to leave the answer in base e. Okay? That's what's going on here. But now, once again, reminder, ln means log base e. Okay? So keep that in mind. So now, starting from this equations, 5 plus 6 ln x equals 70. What I'm saying here, it is not in ordinary form yet. This is not in ordinary form. Okay? So what I need to do is I need to subtract 5 from both sides and bring that to 6 times natural log of x equals 12, and I'm dividing 6 from both sides, and that gives me natural log of x equals 2. And at this point, my equation is in ordinary form. And then now you can think about that equation here. You can think of that as log base e of x equals 2. And so at this point, everything comes easy for me. Okay, rearranging the quantities. The x here would be my expressions. The e here would be my base. Okay, and the 2 here would be my number on the other side. So now rearranging the 3 terms here, how do I rearrange them? E would be the base, power 2 equals x. And so here's the answer, amazingly. Okay? That's just the answer. X equals e squared. X equals e squared. And that's what the course compass is asking for. That's what the answer we are expecting. Okay? Leave the answer in base e. Okay? Problem number 14. So now here it comes to the first time that you're looking at an equation that has 2 log terms. Log base 12 of x plus log base 12 of x, of 11x minus 1 equals 1. Okay, so now I have an equation here. We want to solve for x. And this this equation, once again, notice it has 2 different log terms. But then the good thing, they're still having same base 12. So what I can see here is that, first of all, I need to bring that back to my ordinary form. And the way of doing that is, the only rule that we know so far is based on rule number 1. You can combine the 2 separate logs here into 1 log. So what I can do, the left-hand side can become log base 12, and then the 2 expressions x, I'm going to multiply x to 11x minus 1. Okay? So what I just did here is I multiplied the 2 separate expressions into 1 product, and then I take log base 12. So now I combine my left-hand side into 1 log problem, 1 log term, and equals 1 on the right-hand side. So here I am at my ordinary step. I have the base, that's my base. Okay? There's the expressions. Okay, and here's the number on the right-hand side. Number on the right-hand side. Okay, on the right side. So now it's just now the matter of rearranging these 3 quantities there. So what I'm seeing now is that I can do base 12 raised to the power 1 equals to x times 11x minus 1. So now really this equation here turns out to be a quadratic in the sense that we have 12 equals to 11x squared minus x, or rearranging the 3 terms here, you have 11x squared minus x minus 12 equals 0. Okay? And here when you attempt to solve for this problem, right? And we have learned how to solve for this problem, right? So I'm going to hold the problem right here, and leaving the solving to the final answer for you. But make sure in the end when you solve for the final answer here, actually let me quickly work it out. I mean, I'm gonna leave the middle steps, have to solve that for you here, but then the two final answers for this equation, let me see. We are going to have okay, so I have one answer here is to be 12 over 11, and the other answer is going to be -1. Okay, so I found my two answers. But once again, be cautious. Do not rush into concluding that these two would be your final answer yet. You need to check. So, check by plugging in. You're going to go back to your starting equations, okay, and plug the first answer that you found, 12 over 11. Plug that into the equation and find out if that the two sides actually going to equal to each other. So what I have here is going to be log base 12 of 12 over 11, okay, plus log base 12 of 11 times 12 over 11 and minus 1. Are these all going to be equals to, and put question mark on that equal signs, are they all going to be equals to 1? So the left hand side, as we work it out, it can be, it's going to be 1 minus log base 12 of 11, okay, and then you adding that to inside the log, you can cancel out the 11, and that will give me log base 12 of 11. Okay, so canceling these two, then yes, it will be equal to 1. So the first answer here does work. Now checking with the second answer, you need to check again. Okay, so I have log base 12 of 1 plus log, of -1 plus log base 12 of 11 times -1 minus 1. So right at the beginning, and by the way, here we would like to see if it's equals to the right hand side. Okay, but right at the beginning, log of negative number, we cannot do that. So this answer here is not going to count because you cannot plug that into log function. So now, in the end, really your solution, there's only one solution. X equals 12 over 11.